The next presentation will be made by myself, so I give the floor to myself. I will talk about Racurs' company experience in working with KOMPSAT imagery. I changed the chairs now. So in this presentation, I will share with you our experience in working with KOMPSAT satellite images. As you understood from some of yesterday's presentations, Racurs offers a wide range of possibilities for processing all kinds of data: optical, radar, and spaceborne imagery. We can see here a fairly complete list of sensors that Photomode supports. These are KOMPSAT 2, 3, 3A are marked in red, as I am planning to focus on those in my speech. For full-fledged support of data, apart from developing algorithm, you have to conduct an exhaustive data testing. This will allow you to obtain data that you can reference against some benchmarks. So this is a list of test or pilot projects that we did with various data starting in 2005. As you can see, the number of projects was big, and those projects increase in numbers as the number of satellites is increasingly growing on the market. Apart from development effort, we are also distributors of remote sensing data. So conducting pilot projects is never too much of a challenge. Operators are willing to supply us with the data, and such pilot projects are interesting for us because we are the developers of the algorithm. We need to make sure, check, recheck, and verify that the data is processed by our software properly, and we need to be able to know what outputs to expect. And data suppliers, data providers are interested in pilots, as this helps them promote themselves on the market. Recently, a Submeter resolution images from KOMPSAT 3A have hit the market. We signed a distributor agreement with SI Imaging, and last year we agreed on doing several pilot projects to capture images with their satellites and process them later with Photomode. Mr. Choi from SI Imaging has provided some data characteristics. So this is indeed Submeter data up to 40 centimeter. They have nice non-standard capture time, acquisition time after afternoon. So we captured a portion of the Crimea Peninsula with a stereo pair. The convergence angle has been fairly big, which positively affected the accuracy. For orientation of stereo pair, we used 7 ground control points with at least 20 centimeter accuracy, and these are the orientation results. When no GCPs are used, only RCPs, the accuracy was 15 meters vertically, 18 meters horizontally, which is in line with sensor specifications. The usage of one ground control point lessened vertical error, horizontal error by 1 meter, and vertical error by 60 centimeters. And when all GCPs are used, we obtained subpixel accuracy both horizontally and vertically. Following the orientation, we generated a pixel by pixel dense model using a GM method of naturally Photomode. This is how it looks. It should play as an animation now. Yeah, here it goes. It turns out that we have ultracam data of 18 centimeter images for this area. So with the same spacing, we generated dense DSM, understanding that stereo pair-based DSM is a reference point. So we perceive the difference between two models as an error obtained through space stereo pair. So this is the difference of models and the histogram of error distribution. As you can see, there are no big blunders, and the RMS deviation is about 60 centimeters. Indeed, this is incredible accuracy. When we are asked about accuracies of stereo, about elevation measurement, we usually say 2 to 3 pixels. I'd like to underscore that we had a favorable terrain for stereo pair and a good resection angle, plus good geometric quality from KOMPSAT 3 was also helpful. This is a 3D model with ortho image overlaid on it. This was the first pilot project this year at the request of Aleksandr Forest Agency. 2 more pilot projects have been implemented. First for Leningrad region, and the second is interferometric pair for forest area in Irkutsk. First, we can see that this is October 26 image. No cloud cover. Unfortunately, those Aleksandr and Forest project did not have time to properly process this stereo pair, so I will only walk you through possible applications. The idea of the experiment is to evaluate applicability of stereo images from KOMPSAT 3 and 3A for solving stereo taxation issues, forest taxation. So we're interested in changes of height and the canopy closure, canopy density. This is a free model. We don't know how high these trees are. The model showed about 16 meters. But we'll see with our colleagues from Forest Design Company whether it's accurate. And this is an illustration of canopy closure. So as you can see, it is usable, but when it comes to accuracy, we need to check it with the end user. The second pilot is in Irkutsk. We received two interferometric pairs. The red rectangular shows an area of interest, and the green color shows the boundaries of radar images. The images have been taken within 28-day interval. Initial images were taken in late August, and then in late September. KOMPSAT 5 satellite information is provided on the slide. This is an X band satellite, 28-day revisit time. We used radar, Photomode radar software that we mentioned before. It enables processing any radar data available on the market, and it can perform such tasks as geometric correction, georeferencing, geocoding, obtaining relief models through stereo processing, displacements, marine applications, detection of ships, ship detection, oil spills, and whatnot. We can see images from interferometric pair loaded into Photomode radar. This is the end of August on left and the end of September on right. Radar images are perceived totally different as optical ones, especially when you zoom in on them. Here the purpose was to locate forest logging, but since this was interferometric pair, Photomode radar, well, you can see here that in fact those logging areas are visible even without any processing. This is the same in pseudo color. Since we're dealing with interferometric pair, Photomode radar can perform coherent matching when two images are matched with high accuracy, and then we can overlay one over the other and see the differences. The brighter the pixel tone is, the more likely it is that some changes have happened here. We can very clearly see some bright spots. They're dark, in fact, but they are lighter against the general background. But still we have no verification, no confirmation from our colleagues who used it, but I'm sure this is exactly how it shows on their computers, these logging areas. And below are areas where logging has taken place. That's all I have. That's all I wanted to share with you. If you have any questions, I'll gladly ask them. And once again, I would like to thank SI Imaging Services for pilot tests and test imaging. Thank you for that. Your questions, please.